Hey geometry students, it's your teacher, and we're into 11.5, area of circles and sectors. Alright, got two equations. Actually we've got two equations, but we have a proportion as well. Area of a circle. Leave answers in terms of pi. As a scribble scratch here. In terms of pi. Okay, translation. Don't use 3.1414159. Don't use 3.14. Just use pi. Okay. Unless otherwise specified, if you use pi in the pi key and then you have the round, that's fine. But use the pi in your calculator. But more often than not, just leave it alone. Just leave it as pi. So if the answer was 3 times pi, just call it 3 pi. Okay? In your book, you've got the proportionality of this one for area sector. Alright? It's got area it's got, if you look at it, it's got measurement of area of sector divided by 360 equals, you got measurement of AB divided by 360, or in the other one in terms of pi. Okay, if they solve for area sector with the cross multiplication, that's where you got the equation came from. Okay, so again, using proportionality. So if you look into your equation there, it says area of the sector divided by the area of the big. So area small divided by area big equals, and then measurement of angle of the sector divided by the measurement of a circle, and it's 360 degrees. Okay, we know that. I know we didn't cover circles, but this is bare bones here and pretty straightforward. So I'm going to keep grooving. Guided practice numbers 1 through 3. It says find the area of D. So we got some grammar going on there. It's got a little circle and then D. Okay, so it says area of circle D. That's the symbol for circle. And then of sector, if I go back to this one up here, that's the symbol for sector. Measurement of sector AB. If I just wanted sector AB without the measurement, like if I was doing congruency, that would be the symbol for sector. Okay, just has a little curvy line above, little halo type thing above. All right, so it says number one, how do I find that? Well, I want to find the area of this. It tells me it's 14. Area is of a circle is pi times 14 squared. Okay, so that would be area is 196 pi. Okay, we bump pi on the back end, just kind of keeps it neat, a little bit neater. Let me just there we go, a little bit more light here. Put pi on the back end. You don't say pi 196. Call 196 pi. Could you round to the nearest whatever? Sure, but let's leave it in terms of pi as often as we can. Okay, second one, it says find the area of the red sector. So that's the area of the red sector. So I have my formula. It says measurement of the sector. So that's going to 120 degrees divided by 360. Divided by 360 multiplied by pi times 14 squared. Okay. We already know that's 196 pi, so 120 divided by 360 is 1/3. And then, we divide 196 times the answer. And so, let's see. There's second sector. Alright, there it is, sorry. 65.3 repeating pi. You can leave it in terms of fractions if you want. But or we could multiply this out, but I kept it in terms of pi. Okay, if I wanted to get an even, this is an approximate already, so multiply by a second pi, and it's going to be approximately 205.25. Okay. They didn't provide, they did, actually, I forgot units here, so this one's not 100% correct, because they did provide units, so this needs to be feet squared, and area of a sector, that's indeed feet squared as well. Okay. Finally, the last one, it says find the area of the blue sector. So that's the red sector. How do I find the blue sector? How in the world am I going to find this angle? Okay. Well, if we know that this is 360 degrees, then 360 degrees minus 120 degrees is going to be 240 degrees. So the area of that sector is going to be just 240 degrees divided by 360 multiplied by pi times 14 squared, same thing, because it's multiplied by the area of the circle. So 14 squared multiplied by 240, 360, so 130.66 repeating feet squared pi. Squeeze pi in there. Don't forget your little pi. That makes a big difference. Okay. So you can leave your answers in terms of pi. I love the answers left in terms of pi. And so there we go. Okay, I'm going to keep moving. I'm going to set up the next problem. Okay, so I've got a little Batman symbol here. Very ugly drawing, but I don't care. Alright, so a nice happy circle, and then this circle is within this circle. These two circles are congruent, and I want the shaded region of the Batman symbol of the negative space, or the, I guess, negative space, whatever it's negative, positive. Doesn't really matter right now because actually this would be negative space, but regardless, okay. How do we find this? Okay, well, typically in a situation like this, it's going to be the area of big circle, area of big circle, minus the two small circles. That's my general formula. This is so key in geometry. So it's the area of the big minus the area of these two small ones, because they're both congruent. So what if I find this? So how do I set this up? Well, hopefully you can see if this is 3, then this would be 3 as well. Okay, so the total diameter of this is 6. Or, since it's a circle, I could also draw a line there, and I could also draw a line there, I could also draw a line there. So I could actually think about the whole thing. If these 3, 6, 9, 12, the diameter is 12. Okay, well, half the diameter is 6. Or I could think of this being, from here, being 3 and 3, so 6 units long. So the radius of the big circle is 6 units long. So this is simply going to be pi r1 squared minus 2 times pi times r2 squared. You know me, I love subscripts, so I've got the subscripts going on here. So then pi times 6 squared minus 2 times pi times 3 squared. Okay, 6 squared is 36, so 36 pi. Rearrange that. 9 times 2 is 18, so 18 pi. Final answer, 18 pi, and it looks like meters squared. Don't forget your units there. So 18 pi meters squared. All right. You could, if it asks for a decimal approximate, you can certainly multiply by pi. So again, area of the big minus the two small ones. Okay. Let's stretch it out. Let's work a little more challenging ones. Okay. So this is number 18 in your book. This one gives us a lot of information here, and I didn't shade the region in very well because, yeah, I didn't do it. Okay, so we want the shaded region, okay? We got a lot of things that we have to analyze here. This is what they gave us. So with these parallel lines and the fact that these are congruent, we can conclude, and you have to go back to parallel lines. Actually, this was proportionality, dealing with similar figures, and we can determine that this is congruent, and that's key. So what that means then is from there we can see if this whole length is 8 units long, then this is going to be 4. So half the battle in geometry is just finding the missing unit or missing value. So now I love my general. I want you guys doing this in your work and test quizzes. This is so key. I want to see you write this step down. Area of trap. Okay, it's going to be the area of the trapezoid. Okay, minus the area of 1/2 circle. Okay, and I'm going to rewrite that because there's another word for half a circle. It's called a semicircle. So the area of the semicircle. Okay, so area of the trapezoid, area of trap. And if you want to draw a picture, you could do that too. And it could be like area of trap minus area of semicircle. You could draw a picture of a semicircle instead of writing the words out. Okay, so what's the formula for a trapezoid? 1/2 height times base 1 plus base 2. Okay, minus, all right, area of a semicircle. Well, semicircle, so it's going to be semicircle is 1/2 pi r squared. Okay. Okay, so plugging in the parts. Let's see. So base 1, that's 20. Doesn't matter which one you put where. Addition's commutative. Base 2 is 16. Total height is 8. So following that out, calculating that out, it's 144, and then 1/2 times pi times 4 squared is 8 pi, and then this is a time where not leaving in terms of pi is the better idea. So this is 118.87, and don't forget this. I often drop my units in the work. I just remember to always put it back in the answer. So don't forget to put your units back in your answer. Okay, let's keep moving. All right, so the final problem we're going to do is this one. It's a lot prettier in the book here. I just scribbled this down. Art teacher would be totally offended, but I'm going to go because I got seconds. Okay, so we've got this. It's a little scribbly here. So this is the radius of the green circle. Okay, and the problem gives a lot more information, which helps us out. This circle is inscribed here. So what that means is we know that then the diameter of the big giant circle is going to be 8 units. We also know that this distance here is going to be 8 units. Okay, so how do I find the area of the green section? They said leave in terms of pi. So that's just simply going to be pi r squared. Okay, the little one, so that's just going to be, since that's 4 squared times pi is just going to be 16 pi. Okay, the pink one, all right, is going to be, they gave us the angle of measurement at RPS, so that's going to be 108 degrees divided by, oops, forgot unit squared here, that's area, so unit squared, 108 divided by 360 multiplied by pi r squared. In this case, r is 8. Okay, it's not 4, it's this whole length, which is going to be 8. So pi r squared here, let's see, this turns out to be, I have it written down for you, 19, let me double check, I'm going to double check my math here, 64 times 8, yes, 19.2 pi units squared. And then finally the last one, this is my favorite part here, guys. This is going to be big circle, okay, minus the sum of sector, or in this case it's going to be pink, plus circle, or we could just do green. Okay, so the orange is going to be the big circle minus the sum of these. So the big one minus these two gives me the almost Batman symbol here. Okay, so how do I find the big circle? That's going to be pi r squared, so that's going to be 8 squared. That's the diameter of the big circle is 8 units, minus, hey, we already did those, so 19.2 pi plus 16 pi. Alright, so 64 pi minus 35.2 pi. Okay, and then adding those two together gives me 28.8 pi units squared. Okay, so a review. Okay, the small one giving us there, the pink section using our sectors here, and then orange. You got to be clever and figure out, okay, it's the big circle minus the sum of these two. This is so important, guys. I love this step here, so please, please, please show that in your work. All right, I think that's about all we've got for today. May the Lord bless you and keep you. I'm signing off.